Okay, class, so today we're going to talk about calculating and comparing simple and compound interest. Now, back in Module 3, we briefly touched on simple interest, but in this module today, we're going to be talking about comparing both simple and compound interest. Okay, one vocabulary word that we have compound interest. And compound interest is the interest that is paid on the principal and on the interest an account has earned. Okay, now here is a formula for interest we'll be using. We'll look at this a little bit later. It's the amount equals the principal times 1 plus the rate. And this means this is actually the exponent, which is t, the time. Okay. All right, so let's jump right in here. We're going to calculate simple interest as a refresher for you. All right. And just in case we don't remember simple interest, it is I equals, so interest equals principal times rate times time. Okay. All right. So now I taught you back in Module 3 to go ahead and list out each variable, and we'll plug it into the formula. Okay. So let's look at our example here. It says each year Monica deposits $200. So she deposits $200 each year. So every year she's going to put in $200 into her savings. It earns simple interest at an annual rate. Annual, that's our time, rate of 3.5%. So we're going to make a table to show how the interest grows over 3 years if she makes no withdrawals. All right, so now, excuse me, we're going to break down what it is here. So we're looking for the interest. So we're questioning that. We don't know what that is. So we're going to put a question mark there. Okay, the principal. What did she start with? She deposited $200. So that's where she began at $200. Our rate is 3.5%, which we always know that we need to turn our percent into a decimal. Okay, so we move that over 2 places. So our rate is 0.035. And our time, which is the amount of years, annual means 1. Okay, that's our time. All right, so now we're going to make 3 deposits here. So 1, 2, 3. So now on our first deposit, okay, she started out with $200. So we're going to put $200 here. Okay, so now we're going to figure out what our interest would be for that first deposit. So we would just plug it in, 200 times our rate as a decimal, 0.035 times 1. Okay, and once we would calculate that, we would get 7. So our interest would be $7. Okay, so now it says each year she deposits $200. So our balance on the second deposit would be $400. And it would be $400 because each year, this would be years, she deposits at $200. So she started out with $200. So the next year, her balance is now going to be, she's going to deposit another $200. So now let's see how much her interest is at year 2. So we do the same thing here. 400, because we're in year 2. 400 times 0.035 times 1. Okay, and once we multiply that out, remember, multiply the first 2 numbers, get an answer, and multiply it by the last one, and we would get 14. Okay, so my interest here would be $14. Okay, so now I want you to take a moment. I want you to talk with your partner, and I want you to tell me what the balance would be at year 3 and how much interest would be accrued, and then give me the total interest for those over those 3 years. Okay, so what you should have come up with your partner is at year 3, the total would be $600. Okay, and to figure out what the interest would be, we would do 600 times 0.035 times 1, which would give me 21. Okay, so my total interest accrued over 3 years would be $42. Okay. Okay, so now we're going to jump to calculating compound interest. Okay, and in this example, we're actually going to use the table to show how we calculate this. So let's look at our example here. It says on each birthday, Eric deposits $200. So on each birthday, he's going to put in $200, okay, into his savings. It earns interest at a rate of 3% compounded annually. Okay. We're going to make a table to show how the interest grows over 3 years if he does not take out any money. So if he doesn't withdraw anything at all. Okay. So we're going to do the same thing we did here. We're going to make 3 deposits. Okay. So our first thing we're going to do is our first deposit, our new balance here, would be $200. That's the amount that he started out with. Okay. So now we need to figure out how much interest he's earned here. So we're going to do 200 times our rate, which would be 0.03. Okay. All right. And that would give me 6. Okay, so my interest earned here is $6. So my ending balance at year 1 is 206. Okay, so now the thing with compounding, we're going to take this balance and it's going to roll over to year 2. But then we also know that he's going to deposit another $200. So our balance here for year 2 is 406, which would be what we have here. So 406. Okay, so now we're going to do the same thing here. We're going to figure out what my interest is here. And this is understood as 1 there. Once you understand that annually is 1, we're just doing that times 1 because annually means 1. We didn't leave that out. This would be the same thing if we just multiply those 2 numbers. Okay, I just don't want you to get that mixed up. All right, so now we would do 406 times 0.03, which would give us $12.18. So now my interest earned here is $12.18. So now I'm going to add these 2 numbers here. So I'm going to add this column plus this column, which is going to give me this one. Okay, so now I'm going to get 418.18. Okay, so now what I want you to do with your partner is I want you to figure out what his deposit phase would be for year 3. Okay, so what you and your partner should have come up with is, okay, we're going to roll over this amount to year 3, and we're going to make another deposit of 200. So 418.18 plus 200 gives me 618.18. Okay, and we do our same formula here. 618.18 times 0.03 gives me $18.55 in interest earned. So I would add these 2 columns here, and I would get $636.73. So here is how much interest he's gotten over 3 years without making any withdrawals. Okay. All right, so now we're going to move on to calculating simple and compound interest. Okay, so on this example here, we're going to do something a little bit different. We're actually going to use the formulas to calculate these two. Okay, so in our workspace here below is where I'm going to show you how to do this. So we're going to do simple interest here on this side, and we're going to do compound on this side. Okay. All right, and if you want to, you can go ahead and write down the formulas. I equals PRT. A equals P times 1 plus R to the T. Okay. All right, so now that we have our formulas written down, let's look at our example here. It says Taylor deposits $150 in each of the two savings accounts. Okay. She deposits $150. Okay. Both have an annual interest rate of 4%. So an annual interest rate of 4%. No additional deposits or withdrawals are made. One account earns simple interest and the other account earns interest compounded annually. Which account will earn more interest over 20 years? Okay. And how much more? All right, so now let's break this down here. Let's calculate our simple interest first. All right, so now we're trying to find our interest, so we don't have that. Our principal amount would be the $150. That's how much she deposited. That's what she started with. Either way, in both accounts. Okay, so I equals $150. Okay, my rate would be 0.04. And my time would be 20. Let's go ahead and put the principal here. 150. Okay. All right. So rate is 0.04. And my time is 20. All right. So now what I want you to do here is I want you to calculate this with your partner and give me how much interest would be accrued for this simple interest side. Okay, so what you should have come up with there is interest was 120. Okay, so now the question is, what do I do with that 120? Okay, because that's the amount of interest that she earned. So I want you to talk with your partner and tell me and discuss what will we do with that 120 now. Okay, so what you should have come up with is you should have added it back to your principal because we're trying to see how much will be in the account after the 20 years. Okay, so this one with simple interest would be $270. Okay, so here's what this is what the number we're going to use for simple interest. Okay, so now for compound interest, we're going to use the same numbers here, plug it into our formula. Okay, so A equals the principal amount, which is 150. Times 1 plus the rate would be 0.04 and T would be 20. All right. So that's 150 times 1.04 to the 20th power. Now what you're going to have to do here, you're going to have to use your calculator to figure out what that is. Okay. All right. So now I want you right now and do order of operations here in order to figure out what this would be. All right, so I'm going to give you about 30 seconds to use your calculator and figure out what 150 times 1.04 to 20th power would be. Okay, so what we should have gotten here was 2.19. So it's 150 times 2.19, which would give me $328.50. So now my question can be answered now. It says, which account will earn more interest after 20 years and how much more? That how much more means we're going to do what? Subtract. Okay, so looking at this, which account, would it be the one with the simple interest or would it be the compound interest account? Okay. And clearly we can see that it'll be the compound interest account. But we need to figure out by how much. So that's what I want you to figure out now with your partner. By how much more would that compound interest account earn more? Okay, so when you subtract it, you should have gotten $58.67 more. Okay. All right, so the compound interest account will buy $58.67 more. Okay.